64 light-years from Earth, there's a planet that looks almost gentle from a distance. A deep, saturated blue, not unlike the color of Earth seen from orbit. But that blue isn't water. It's glass. Silicate particles, condensed high in the atmosphere, whipped sideways by winds clocked at over 5,000 miles per hour. On this world, HD 189733b, the rain doesn't fall. It's fired, horizontally, hard enough to strip skin from bone in seconds. But take that same idea and move the planet close enough to its star that the rock itself gives up. That's K2141b. No oceans, no solid ground worth the name. Just a molten sea stretching across an entire hemisphere with surface temperatures near 5,400 degrees Fahrenheit. Even the atmosphere is wrong. It isn't gas boiled off water. It's vaporized stone. Rock that evaporates over the day side, drifts to the night side, and falls back down as it cools. Solid mineral rain, out of a sky made of stone. Now take away the star entirely. Somewhere out in the dark, between solar systems, planets drift with no sun to orbit. Astronomers call them rogue planets, and current estimates suggest there could be billions of them scattered through our galaxy alone, kicked loose from their original systems long ago. No sunrise, no warmth, no light at all except starlight, too faint to matter. Just permanent, absolute night. Forever. That kind of isolation is unsettling, but at least a rogue planet holds still. The next object doesn't. A star called S5-HVS1 was once orbiting near the center of the Milky Way, until something violent flung it outward at more than 4 million miles per hour, fast enough to escape the galaxy's gravity entirely. You can relax for now. It isn't headed toward us, but somewhere in this galaxy, a star very much like it could be, and we might not know until it's already reshaping the paths of everything nearby. Take a star, though, and let it die the ordinary way, and something even stranger waits on the other side. When a massive star's core finally collapses, it can crush down into a sphere barely 12 miles across, while still holding more mass than our entire sun. This is a neutron star. A single teaspoon of it would weigh roughly 1 billion tons, heavier than every car on Earth combined. Land on one, and you never really would. Gravity would stretch you into a thread of atoms long before you touched the surface, and slam what's left of you down at a meaningful fraction of the speed of light. Wrap that same collapsed core in the strongest magnetic field known to exist, and you get a magnetar. Come within 1,000 kilometers of one, and its field would start interfering with the electrical signals running your nervous system. Your muscles would seize, your vision would fail. Not from heat, not from impact, from a magnetic field doing to your body what it does to steel from miles away. Here's the good news. Everything so far sits thousands of light years from Earth. None of it is coming for you. Not tonight. But not every threat announces itself with distance. Some announce themselves with light. When a dying star focuses nearly all its energy into 2 narrow beams instead of releasing it in every direction, the result is a gamma ray burst. The most violent release of energy known since the birth of the universe. In seconds, it can output more energy than our sun will produce across its entire 10 billion year life. If a burst like that struck Earth head-on, there would be no warning. The radiation travels at the speed of light. The first sign would be the sky already burning. Somewhere in this galaxy, black holes are moving that even light can't announce. When a star's collapse is lopsided, the newborn black hole can be hurled outward at millions of miles per hour. Dark, invisible, completely undetectable, except for the rare moment it passes directly in front of a background star and bends its light. Astronomers believe there could be tens of millions of these rogue black holes drifting silently through the Milky Way right now. Most will never be found, but you don't need a wandering one to feel unsettled. There's a fixed one at the center of our entire galaxy. Sagittarius, a star holds roughly 4 million times the mass of our Sun, compressed into a region that, from Earth, would look no bigger than a tennis ball placed on the surface of the Moon. Every star you've ever looked at is orbiting it, including our own. One full circuit takes about 230 million years. The last time our solar system completed a lap, there were no flowers on Earth yet. Sagittarius A star is enormous by any human measure. It's still small next to what's out past it. A quasar called 3C273 sits roughly 2.4 billion light-years away, and for decades, it baffled the astronomers who found it. A point of light outshining entire galaxies, powered by a supermassive black hole feeding on infalling gas so violently that the friction alone heats material to temperatures that outshine every star in its galaxy combined. It looks like a star. It behaves like nothing a star could ever be. Even that isn't the ceiling. TON 618 holds an estimated mass over 10 billion times that of our Sun. So large that if it replaced our Sun tomorrow, its event horizon alone would extend billions of kilometers past Pluto's orbit. Every planet you've ever known would already be inside it, past the point where nothing, not light, not matter, not information, can ever come back out. You'd think the scariest thing in the universe would be something enormous like that. But some of the most disturbing discoveries are the opposite, their absences. The Buddha's Void is a region of space roughly 330 million light-years across, containing almost nothing, a handful of galaxies where there should be thousands. Nobody has a confirmed explanation. It might be a natural gap left over from the universe's early structure. It might be something else. Scientists can't rule it out. And while that void sits empty, something unseen is pulling entire galaxy clusters, ours included, through space at roughly 600 kilometers per second toward a single point we cannot directly observe, hidden behind the crowded core of our own galaxy. Astronomers call it the Great Attractor. We can measure its gravity. We cannot see its source. And even the Great Attractor itself is being pulled toward something larger still. The Shapley supercluster, the single densest concentration of matter in our cosmic neighborhood, dragging entire superclusters toward it with no way for anything caught in its pull to resist. But every structure so far, every star, every void, every black hole, still obeys the same basic rules of physics. The last place doesn't. Empty space isn't actually empty. It's filled with an invisible energy field called the Higgs field, and it's the reason atoms hold together, the reason matter has mass at all. Right now, physicists aren't certain the Higgs field is sitting at its lowest possible energy state. It might be balanced on a ledge, the way a boulder can rest on a mountainside without having reached the valley floor. If a random quantum fluctuation ever nudges it off that ledge, a bubble of altered physics would begin expanding outward at the speed of light. Inside it, atoms wouldn't hold together the way they do now. And because the bubble moves exactly as fast as any warning could, there would be no warning at all. This isn't hypothetical panic. When researchers confirmed the Higgs boson in 2012, the resulting calculations suggested our universe may already be sitting closer to that ledge than anyone would like. It might happen in 100 trillion years. It might already be moving toward us right now at the one speed nothing outruns. Scientists have tried to calculate the odds, and the number they landed on is almost worse than not knowing at all. Statistically, a bubble like that shouldn't form for tens of billions of years, if it forms at all. But quantum events don't follow a schedule. They don't wait their turn. A fluctuation like this could occur at any single instant, with no buildup and no pattern to watch for, which means the calculation